Well, good day, everybody, and welcome to the Thought Edition of 5 Minute Psych. In this 5 minute segment, we'll look at decision making, starting with some simple strategies that we use. Then we'll focus on risky decision making or decisions that are made without knowing what the outcome will be. And finally, we'll end with a discussion about heuristics in decision making, and we'll see that since we make a lot of errors in estimating the probability of events, our decisions may be flawed. We'd like to think that we're good at making decisions, but some decisions can be very difficult, like which university should you choose, A or B? Maybe University A is closer to home, more of your friends are going there, but you only got into your second choice for your program, while University B is farther away, none of your friends are going there, but you got accepted into your first choice for your program. One way to approach this is by elimination. If you have some minimum criteria that has to be met, like maybe you have to live at home, so you can eliminate any universities that are too far away. Otherwise, you could use an additive strategy where you rate each of the attributes on a scale from maybe 1 to 10, and then choose whichever option has the highest total. You could also assign weights to the different attributes, like maybe getting into your first choice is twice as important as having old friends there. We often make decisions without knowing ahead of time what the outcome will be. We're making a risk with our decision, and although we should choose the alternative with the greatest expected value, we don't always do this. We buy the lottery ticket when our chance of winning is less than the chance of getting hit by lightning. We park in an illegal spot even though we could get a ticket. Why? One reason has to do with subjective utility, or what the outcome is personally worth to us. Yes, the lottery ticket costs $5, but that cost is worth holding on to the dream of potentially winning for a week. Yes, we could get a $30 parking ticket, but that cost is worth the walk when it's -20 and you forgot your gloves. But sometimes we make these decisions because we're wrong about how often these events occur. We use many heuristics to estimate the probability of events around us. And although these heuristics are fast, easy strategies to turn to, they can also be wrong. There are 4 different heuristic strategies that we use in decision making that can lead us to make errors. One is the availability heuristic, where we estimate how often something happens by how easily an example of it comes to mind. That's it. If we can quickly think of an example, we think it happens all the time. But if we struggle to think of an example, then we conclude that this must be a really rare thing. For instance, do you think there are more words in English that begin with R or have R in the third position? Most people conclude begin with R because they can more easily think of examples here than R in the third position. But they'd be wrong. The representativeness heuristic is when we estimate how often something happens by how similar it is to the typical case. For instance, imagine you roll a 6 on a die 10 times in a row, and I ask you, how likely is it that the 11th toss will be another 6? Most people say it's less likely to be a 6 because overall, they know that there's a 1 in 6 chance of getting a 6, but because they already had 10 sixes, the other numbers are well overdue to turn up. But they forget that every toss, even the 11th toss, the chance of getting a 6 is still 1 in 6. We also tend to ignore base rates or the broad likelihood of something happening. For example, suppose you heard that they found a new study tool that guaranteed a student earned 80% in their psychology course. Should you go buy the study tool? Many would say, of course, with grades like that. But you'd have to ask what the average grade would be without the new study tool. If it's also 80% in the psychology course, then why bother? But we may not even think to ask something like that because we ignore base rates. Finally, we're guilty of the conjunction fallacy, where we estimate the odds that 2 events will occur together as greater than the odds of either of these events happening alone. For example, suppose you meet someone who is very quiet and reserved. Is it more likely that this person is a parent, or a parent who is also a librarian? Most people say parent and librarian because of the traits quiet and reserved. Go with librarian. But look here, we have parents represented by this circle, librarians over here, and the chance of someone being both is this tiny intersection here. It's impossible for this intersection to be bigger than any one of these circles. Well, we just explored decision making, beginning with some simple strategies that we use. Then we examined heuristics in risky decision making, where we estimate the probability of the events around us. We saw that since we make a lot of errors in these estimations, that our decisions could be flawed. Now, aren't you glad you had 5 minutes?